Hello, hi everyone. Welcome to the Student the Brand. This is our Shiva sir. Today we are going to discuss about human eye and colorful world CBSE Grade-10 physics. So welcome to the Student the Brand channel. Here I'll explain in detail about human eye and colorful world. So we'll see. So if you close your eyes, will you able to see anything? If you close your eyes, will you able to see anything? Just to close your eyes. Open your eyes. Will you able to see anything? No, we can't able to see anything. Once you close your eyes, will you able to see anything? No. When you close your eyes, you can't able to see anything. Once you open your eyes, only you can able to see the beautiful world in front of us. Yes or no? So we can able to see the beautiful world in front of us. So with our eyes only we can able to see the world. With our eyes only we can able to see the world. Okay. So human is the most sensible and sensitive organ. Most sensible and sensitive organ in our human body. Today we will completely discuss about human eye and colorful world. Human eye and colorful world. So now you can check once. Human eye and colorful world topic. Human eye and colorful world. So in this topic, we'll discuss about eye parts and function, especially human eye parts and function. Human eye parts and function will discuss. Human eye parts and function. Human eye parts and function will discuss. Right? Yes. So now you can observe here. So I will draw three. Okay, now so three diagrams. So in easy way, in a simple way, how to draw the diagram. Okay, so check once here. So first to draw the circles. Draw the circle. Then so second step. This is the first step. Second step is, so you can draw only one diagram. In one diagram only you can draw. So you can rub this portion and this portion little bit above. And third step is third step. You can do all the steps in one place itself on one diagram. So I am taking like this. Okay, so like this you can draw. Okay, and this one curved portion. That's enough. Like this you can draw it. Like this. So I'll draw all these steps on one diagram. So just check once. So all these steps I'll draw, okay, in one diagram itself. So just check carefully. So I'm drawing like this. Okay, so like this you can draw. Like this you can draw. Okay, just you can hear the curved portion will be there. So like here and here also. That's enough. Okay, I hope it is very clear. Right? So you can draw like this. And so here line lines, that is eye lines you have to draw. Islands. This islands. Okay. This islands. Okay, so you can observe. You can observe islands. So islands you can understand. Okay. Done. Now so this is humaning. So we are discussing about completely humaning. Humaning. Humaning parts and functions. Humaning parts and functions we are discussing. Okay. Now you can observe here. So like this you can draw. Observe carefully. So this front portion is called cornea. This front portion is called cornea. Cornea. This is a cornea. Cornea. And so this is the iris. And here also down also iris only. And pupil, this gap is called pupil. Pupil. And this is aqueous humor. Aqueous humor. And here, so this portion is called vitreous humor. Vitreous humor. And so here is the blind, here is the retina. Retina. So this portion is the retina. Okay. And here, so we can observe in this portion, this is the optic nerve. Optic nerve. Optic nerve. So this is about and vitreous humor, retina, optic nerve. Now we will discuss on ciliary muscles. Ciliary muscles. Ciliary muscles. And here islands. Islands. So here also islands. It's also ciliary muscles. Okay. So now we will discuss once again. Check once here. So first portion is cornea. Cornea is the frontal layer, protective layer of the eye. Cornea is the frontal layer, protective layer of the eye. Okay, so most of the refraction takes place at this portion, cornea. Okay, so through that refraction takes place, light enters so that. Okay, and here cornea is, next one is iris. Iris is a dark muscular diaphragm which controls the size of the pupil. Iris is a dark muscular diaphragm which controls the size of the pupil. And people will control the amount of light entering into the eye. People will control the amount of light entering into the eye. Okay, people will control and regulate the amount of light entering into the eye. And coming to the ciliary muscles. So when you want to see the nearby object as well as far object, when you want to see the nearby object as well as far object, so ciliary muscles will adjust the curvature of the eyelids. Okay, so it adjusts the curvature of the eyelids so that we can able to see near distance as well as far distance object. So in camera we can able to adjust the focus. Okay, so as soon as you are adjusting the focus, we can see near as well as far. So but here, so automatically we can able to see near distance as well as far distance. Okay, so we can able to see the near distance as well as far distance, we can able to observe. Yes or no? We can able to see here. Okay, so ciliary muscles. So which here, which part is responsible for seeing the nearby object as well as far object? Which object? Which part? Here, ciliary muscles. Ciliary muscles will able to adjust the curvature of eye lens, so we can able to see near distance as well as far distance object. Okay. Next one, eye lens. Eye lens is the crystalline lens, convex lens. Whenever light rays falls on, it will converge and make it falls at retina. And coming to the aqueous humor, it is a jelly type liquid material present between cornea and eye lens. Okay, it is a transparent material. So whenever light passes, so it will allow, and also it provides sufficient blended nutrition to the central cornea. Blended nutrition to the central cornea. And coming to the vitreous humor, this entire portion is filled between lens and retina. Between lens and retina, this entire portion is filled with vitreous humor. Vitreous humor is a jelly type liquid present between eye lens and retina. Eye lens and retina. Okay, so vitreous humor is a jelly type liquid present between eye lens and retina. Okay, so it is a transparent liquid. It provides sufficient force and pressure to the eye. Okay, so by that it can be maintained that shape. Coming to the retina. So retina is a light sensitive screen. So here is the retina. So this is the retina. Okay, this portion is the retina. I hope it is visible to you. So retina, vitreous humor, this is the retina. Retina. So retina is a light sensitive screen. Retina is a light sensitive screen where light rays will meet. Okay, so after passing through the lens will convert the light rays, it make it falls at retina. At retina, so light rays will meet. It is a light sensitive screen. It is a light sensitive screen. Okay, image will form. So real and inverted image will form. Real and inverted image will form at retina. So here, so one more point that is at retina, two types of light sensitive cells are there. At retina, two types of light sensitive cells are there. Those are rods and cones. Rod sense the intensity of the light. Rod sense the intensity of the light. Cone sense the color of the light. Rod sense the intensity of the light. Cone sense the color of the light. If more rods are there, we can able to see during night time also. Owls can able to see during night time because they have more rods. Okay, owls. Understood? So that is the retina part. And coming to the optic now. So what are the images forming at retina that will convert into electrical signal, electrical impulse that will reach to the brain through optic nerve. That will reach to the brain through optic nerve. Okay, so what are the images forming at retina that will convert into electrical signal that will reach to the brain through optic nerve. Okay, so optic nerve. So these nerves carry the information to the brain. Okay, so these nerves will carry the information to the brain. And one more thing, so whatever you are seeing the 2D object, okay, we are seeing the 2D object. So if you are seeing the object or any chair like book, so you are seeing the 2D object, right? So that image will pass to the brain, so in the form of electrical signal. So brain will add the additional information, how much depth it is, how much width it is, how much height it is. So at the same time, if water is filled half, so how can we get to know water is filled only half? Water is filled 1/4, 1/3, like that. So brain will add the additional information. So that we can able to see that. So that we can able to see the at a 3D image, like how much depth it is, how much height is, how much distance from it is placed. So okay, so where it is placed, like that, everything information, so brain will give to us. Okay, by that we can able to assess the object, how much depth it is, how much height it is, how much range it is from us, everything we can able to analyze. Okay, so done. So that is about human eye parts and function, and blind spot is where all nerves will meet at one point. Blind spot, image form real and inverted, but we see erect image. Actually, real and inverted image only will form. Okay, how can we see erect image? Real and inverted image only will form in the, okay, real and inverted image will form at the retina, but that will reach to the brain, right? Reach to the brain in the form of electrical signals, electrical impulse. Okay, so that will add the additional information. By that we can able to see, by that, so signals row like that only we are seeing like that, right? Okay, same thing. So that is the reason we can able to see the erect image. Erect image in the sense real object only. So real objects and lacking license. Yeah, true, correct only. And you someone saw correct only, that is. So blind spot is here only. Blind spot is here only. So where all nerves reaching to the brain. Okay, so all nerves. So here at this point the blind spot will be there. Okay, so there won't be any light sensitive cells. So no image will form, at the same time no light rays will reach to that point. Okay. Yes, done. Come to the point. So this is about parts and function. This is about parts and function of human eye. And next one we will discuss about refractive defects. Refractive defect. Generally, what is refraction? Refraction is nothing but when light ray is passing from one medium to another medium, so the bending of the light ray and interference of the two media, at the interference of the two media. Okay. So normally if refraction takes place here also, if light rays refract properly, then only image will form at retina. If in case, if the light rays are not, if the lens is not refracting the light properly, if the light rays, if the so the person, okay, actually, he can't able to see that, but he can't able to see near distance as well as far distance object like that. Okay, based on the refraction, based on the refractive defects. So normally, if you are seeing lens should refract when light ray falls on the lens. So here is a lens is here like this. So when light rays falls on it, when light rays are falls on it, so it should refract and make it falls at retina. So if you take it's a retina. If the light rays are not meeting at retina, so by lens only, so lens not refracting the light properly. That's why it is called refractive defects. Refractive defects. Okay, na? Refractive defects. So there are so refractive defects are three are there. Three are there. As of now, according to our syllabus, one is myopia, and the second one is hypermetropia, and third one is presbyopia. Okay, presbyopia. So these are the three defects. Three defects as of now we are discussing in our topic. Okay, so presbyopia, myopia, hypermetropia, presbyopia. So what is myopia? Before that, so few points we'll discuss. Before discussing about before that, we will discuss about near point as well as far point. Near point is nothing but the minimum distance up to which a person can able to see clearly. So the minimum distance up to which a person can able to see clearly. Okay, so the least distance of distinct vision. So the minimum distance up to which a person see clearly. Okay, so distinctively, that is called near point. Near point is 25 centimeter. So if you place the object at 25 centimeter, we can see comfortably. So if you keep on moving towards your eye, so after certain time, so initially you can able to see, after certain time our eyes will get pain and strain. Okay, so at certain distance, so we can able to see clearly. As you move away from it also, we can able to see clearly, so our eyes will be getting relaxed. So when you are seeing the far distance object, our eyes will be relaxed. We can focal length increases. We can able to see far distance object. So when you are seeing the nearby object, our eyes will get strained. So automatically it will be thick. So focal length decreases so that we can able to see near distance object, right? So the minimum distance up to which a person can able to see clearly without any strain or pain, that is called, so least distance of distance vision. Okay, least distance of distance vision is nothing but that only near point. Near point is 25 centimeter. So far point means the maximum distance up to which, the maximum distance up to which a person can able to see clearly. The maximum distance up to which a person can able to see clearly without any strain, that is maximum distance. Maximum distance is infinity. So 25 centimeter to up to infinity we can see, that is the range of vision. Okay, that is called range of vision. 25 centimeter we can see, up to infinity also we can see. 25 centimeter to up to infinity, it is our range of vision. Okay, so next one. So power of accommodation. Power of accommodation is nothing but ability of the eyelens to adjust its focal length. Ability of the eyelens to adjust its focal length to allow the light inside of it. That is called power of accommodation. Ability of the eyelens to adjust its focal length to allow the light inside of it. That is called power of accommodation. That is called power of accommodation. Now we are discussing. Now we are discussing, that is myopia. Myopia. So myopia, 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 myopia. Near distance we can see, far distance we can see. Myopia, myopia, myopia. For that correction, we are using, we are using. Bro, what bro? For that correction, we are using, we are using. Concave lens, concave lens, concave lens, concave lens. So we can able to see near distance, we can't able to see far distance. For that correction we are using concave lens. So that is myopia. Myopia is nothing but the person who can able to see near distance, they can't able to see far distance. Okay, for that correction we are using concave lens. So now you can observe here. So myopia. So I'll give one. Okay. So situation. So the person is standing here. This is the near point. Near point I already said 25 centimeter. This is the infinity. Okay. So infinity point I'm taking, right? Yes. Now you can observe the person can able to see this point. Okay. But he can't able to see the near far point. But between 25 to infinity can see, right? Between 25 to infinity can see, that is called far point of myopic eye. Far point of myopic eye. So he can able to see, he can able to see, he can able to see the far point. Okay, maybe he can't see the this infinity, but certain distance he can see, right? So that is only far point of myopic eye. For the person of myopia, so that is myopic eye. For the who has myopia, for them it is a myopic eye. Okay, so I'll draw the same situation as I said. This is infinity I say, right? Now I'll explain the same situation so you can see. So I'll explain the same situation once again. So I'm person is here. Okay, so he can see 25 centimeter point. This distance he can see. He can't see infinity. He can see 25. But between 25 to infinity, he can see between that point, right? Between this point, he can see. So that is a far point of myopic eye. So we are discussing about myopia. Myopia. Myopia, myopia, myopia. So he can see this point. So to correct, if you correct, automatically if you use concave lens, we can see this point also. How to draw the diagram? So everything I will explain. Just listen carefully. So here you can observe now. Okay. So now you can observe the diagrams like this. Okay. So now, so this is the near point 25 centimeter. This is also near point. This is a far point of myopic eye. So the person can able to see clearly from this point. Light rays are coming from this point, he can able to see. So the image will form at retina. So if the light rays are coming from infinity, so those light rays will meet in front of the retina. So here you can observe. So we are using concave lens to correct the defect of myopia. So this is the far point of myopic eye. Far point of myopic eye. So this is the myopic eye. And this one is the correction of myopia. Correction of myopia. So here you can observe. So these light rays are coming. So this is the near point. This is the far point. So light rays are coming from here. Okay. So if the light rays are coming from infinity after refraction, so it will diverge again, it will converge and meet at retina. So this is a correction of myopic eye. Correction of myopic eye. Correction of myopic eye. Okay. So I hope it is very clear. Just check once. Far point of myopic eye, correction of myopic eye. So this is about myopia. Myopia. So and if you observe these two diagrams, if you observe this one, if you observe this middle one, you can understand. So eyeball is too big, focal length is too small. Causes of myopia. Causes, if they ask about causes, so you can write first one is large eyeball or eyeball is too large, focal length is too small. Focal length is too small. Because of that reason, so light rays will meet at in front of the retina. Or curvature of the eye lens increases. So we can also take curvature of the eye lens increases, then focal length decreases. Understood? So nearby object, we are seeing nearby object, by that focal length power increases, focal length decreases. Clear? Next one we will discuss about hypermetropia. Hypermetropia. So hypermetropy is nothing but the person can able to see far distance, he can't able to see near distance object. The person can able to see far distance, he can't able to see near distance object. Hypermetropia, 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 hypermetropia. Far distance, far distance we can see, near distance we can see. Far distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction, for that correction, we are using, we are using convex lens, convex lens, convex lens, convex lens, hypermetropia, 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 hypermetropia. So that is about myopia and hypermetropia. Now you can observe hypermetropia situation I'll teach. So this is the situation. So I'm standing, a person is standing, he can see far distance object. He can see far distance, like infinity he can see, but 25 centimeter he can't see. But between 25 to infinity, he can see. That is a near point of hypermetropic eye. So normally n is the 25 centimeter, that is a near point. So n dash is the near point of hypermetropic eye. Near point of hypermetropic eye. So that I will explain. I will draw in the diagram format. Just check once. So hypermetropia. Okay. Chalo, chalo, chalo. Again, focus. Okay, so I hope it is very clear. Now you can check once. N dash. Here, the light rays are coming from this point. You can able to see. Light rays, if the light rays are coming from this point, the light rays will meet at retina. So N dash. And if the light rays are coming from near point, as I said, if light rays are coming from near point, those light rays will meet beyond retina. So here the light rays will meet beyond retina. Okay. So if the light rays are coming from N dash, those will meet at retina. So by using convex lens. So now the convex lens, check once. Okay, so if the light rays are coming from N, the light rays will meet at retina. So here again, these light rays will meet at retina. Here. So here. So here, light rays. So if you are extending the light rays from here, now you can check once here. So those extended light rays will meet at this point. This one is the hypermetropic eye. Sorry, near point of hypermetropic eye. Near point of hypermetropic eye. Hypermetropic eye. So this one is hypermetropic eye. This one is hypermetropic eye. Hypermetropic eye. And this one is the correction of hypermetropia. Correction of hypermetropia. Correction of hypermetropia. Okay, so we are using convex lens here. We are using convex lens. So observe carefully. So near point of hypermetropic eye, correction of hypermetropia. Understood? And the next one, presbyopia is there. Presbyopia. Presbyopia is nothing but the person can't able to see near distance as well as far distance. The person can't able to see near distance as well as far distance. For the correction of presbyopia, we are using bifocal lens. Bifocal. Upper portion is concave lens, lower portion is convex lens. And one more thing, astigmatism. So we can't able to identify the horizontal lens, vertical lens properly. Okay, so by using suitable cylindrical lens, we can correct the defect of astigmatism. And one more thing, cataract. Cataract is a defect, so where milky and cloudy will form an eye lens. Okay, milky and cloudy, so we can't able to see the objects. Okay, so by laser surgery only we can able to remove the cataract. So these are the defects. And coming to the next one, colorful phenomena. So related to colorful phenomena, we will discuss about light ray passes through the prism, and next one, raindrop, recombination of spectrum of white light. After that, scattering of light and Tyndall effect. Scattering of light and Tyndall effect. All these points we'll discuss now. Okay, so now you can see here. So next one, when light ray passes through the prism, how it will happen? So if you are taking here, so I'm taking the prism like this. This is a prism, so triangle prism. So light ray passes like this. So here, so light rays will bend here. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, and 7. 7. Okay, the splitting of white light into 7 colors is known as dispersion. The splitting of white light into its constituent colors is known as dispersion. So those colors will form like a band on the screen. Those are called spectrum. So those 7 colors will form like a band on the screen is called spectrum. So violet. So the order is violet, indigo, blue, green. Violet, indigo, blue, green, yellow, orange, red. Vibgya. So order. Okay. So violet, indigo, blue, green, yellow, orange, red. Okay. When light ray passes through the prism, split into 7 colors. Those 7 colors will form like a band on the screen is called spectrum. Splitting of white light into constant colors is known as dispersion. The band of colors will form like a the band of colors. Okay, so the band of colors is known as spectrum. Understood? So this prism, when light ray passes through the prism, split into 7 colors. After that, it will form on the screen. Now, recombination of spectrum of white light. So normally Newton placed normal prism. So he observed the rainbow. At the same time, again he want to split the colors further. So what he placed? He placed normal prism. So besides, so like this he placed. He won't get anything. So 7 colors will form. Again those 7 colors came out. But so next time he inverted the prism. Okay, he placed the inverted prism like this. He placed the inverted prism besides of the first prism. Then, so when you when he sent the light ray, so it split into 7 colors, violet and red. So those 7 colors will enough. After that, so those 7 colors will form like a combined, and so yeah, on the screen it is white light. White light. So it came as a white light. White light. So violet, violet and red, violet and red. and here white light. When you send the white light through the prism, split into 7 colors. Those 7 colors will form on the inverted prism placed beside of the first prism. So prism 1 and this one is the prism 2. Okay. So then it is combined and formed as a white light. Even you can see the Newton disk. So 7 colors you can okay. So 7 colors you can paste like this, and you can paint like this: 1, 2, 3, 4, 5, 6, and 7. Then if you rotate the disc, automatically we can is able to see the white color, right? Yes. So if all colors mix, we'll get white light. So that's enough. This is about recombination of spectrum of white light. Next one, rainbow formation by water droplet. Okay, water droplet. So here, what is the phenomena involved in the formation of rainbow? What is the phenomena involved in the formation of rainbow is, so I'm taking the water droplet like this. So this is a water droplet. Okay. So like this I'm considering. Now, so when white light passes through like this, then it's split into 7 colors. So those 7 colors will form, and it comes out as a like this, all those 7 colors. So what is the phenomenon involved? This is the white light, and you can observe here red and violet, violet and red. So refraction, dispersion, internal reflection. This is the phenomena involved in the formation of rainbow. How? So initially, so refraction takes place. After that, again dispersion takes place. So internally reflection takes place. Okay, light ray will reflect internally. It comes out as a rainbow. So white light we are passing through the water droplet. So first refraction takes place, dispersion takes place, internally reflection takes place. Then we can able to see the rainbow in the sky. Okay, opposite to the sun. Now, so we'll see one more. Scattering of light. Scattering of light is nothing but the re-emission of light in different directions with different intensities called scattering of light. Tyndall effect is nothing but, so the path of the light becomes visible when it is passing through the colloidal solution. So because of colloidal solution, scattering of light takes place. Light ray will scatter in all directions with a different intensity. So that is known as Tyndall effect. And why is planets do not twinkle? Why stars twinkle? So planets are still it reflect, but one place it will be bright, one place it will be dark. So then the overall effect will be nullified. Overall it will be nullified. So it's a point sources. So one will place it will be dark, one place it will be bright. So because of that reason, so the total effect will be nullified. We can't able to see planets are twinkling. Where stars twinkling, so stars are from far distant light ray is coming, because of the atmosphere keep on changes the direction of the light ray. So by that, so the apparent position is changing. So keep on changing. That is the reason that stars appear twinkling. Stars appearing twinkling. That is the one point. And advanced sunrise and delay sunset also because of atmospheric refraction. Coming to the colors. So blue color of the sky and reddish and reddish of the sky. Okay, reddish color of the sky in the evening, in the early morning and in the evening time, because so it is a scattering of light only. Whenever light rays enter, so because of the atmosphere, all the particles will scatter away. So in the evening time, red light has more wavelength. It travels long distance, so that's why we can able to see. In the remaining time, so as soon as light enters from the sun, light comes, so because of the atmosphere, all the colors will scatter away. So blue light will scatter the most. Okay, so shorter wavelength, so it scatters the most. That's the reason we can able to see blue color remaining time. So the evening time, morning time, So as it is distance is more, so all the colors will scatter away. Red light travels long distance. That's why danger signal. So it is in red color because we can able to see from long distance itself. So it is least scattered by the smoke and smoke or fog. Okay, so that's enough. That is about human eye in colorful world. Still, if you have any doubts, you can ask. So we'll discuss. So if you have any doubts or related to this one, you can send a message, or you can chat, or you can go through it. So in the comment section, so you can comment if you have any doubts. So demo class are going on for grade 10 classes. Okay, for grade 10 students, demo class are going on. Remaining subject, not only physics, remaining subjects also going on. So kindly attend to those classes, listen to those classes. If you like that, you can get the classes from the faculty members. So thank you so much for joining and attending and listening my class and giving an opportunity to teach you. So we'll see you in the class, next class. Thank you.